Welcome to The Explainer. Today, we're jumping straight into a macro to micro journey, zooming way down into the invisible world that builds, well, literally everything. If you've ever looked around your house and wondered about the fundamental architecture of reality, you're in the right place. We're going to break down the unseen structures holding our universe together step by step.
Okay, let's dive into this. Picture an everyday object. Maybe it's a metal spoon in your kitchen drawer, an aluminum pot on the stove, a piece of copper wire, or even just salt, charcoal, or a glass of water. If we had a magic microscope and could zoom in thousands and thousands of times past the smooth surface of that copper wire, what do you think it's actually made of at its absolute core?
Well, the answer is tiny particles called atoms. Everything around us, from the solid ground we walk on to the oxygen we breathe, down to the graphite in your pencil, is constructed from these invisible building blocks. It's pretty wild when you stop and think about it. The solid, tangible world we interact with every single day is really just a massive, intricate puzzle made of these impossibly small structures.
Which brings us to Section 1, Anatomy of an Atom.
Before we look at the exact parts, let's ground ourselves with a quick definition. An atom is the smallest unit of an element that still has the properties of that element. You already know the elements from the periodic table, right? Things like iron, carbon, or oxygen. Well, if you take a chunk of pure iron and magically slice it down to the absolute smallest possible piece, that very last piece that still acts and behaves exactly like iron, that's a single iron atom. It's the definitive starting point of all elemental matter.
And when we look closely at that starting point, we find a very distinct layout. You can basically divide the atom into two main areas. First, right in the middle, you've got the nucleus. This acts as the dense, solid center room of the atom. Then, surrounding it, you have the electron shells. Think of these as the busy outskirts of town. They aren't solid walls, rather, they're dynamic areas constantly moving around that center nucleus. It's this incredibly delicate balance between a heavy, stationary core and a buzzing, energetic perimeter.
Let's move to Section 2, Meet the subatomic particles.
Now, what's really interesting here is the tiny cast of characters living inside the atom. We've got a perfectly organized trio of subatomic particles: protons, neutrons, and electrons. Let's walk through their stats together. First up, the proton, symbolized as a lowercase p with a plus sign. It has an approximate mass of 1 atomic mass unit, or AMU. And, as that plus sign tells us, it carries a positive electrical charge. It's home, right in that center room, the nucleus. Next is the neutron. Its symbol is an N with a 0. It also has a mass of 1 AMU, but, like the name hints, it has 0 charge. It is totally neutral. It hangs out in the nucleus with the proton. Finally, the electron, symbolized as an E with a minus sign. It carries a negative charge and lives out in those electron shells, constantly whipping around the outskirts.
But hold on. Look at the mass of that electron for a second. 1 over 1836 AMU. I mean, wow! While protons and neutrons are sitting heavy in the center at 1 whole AMU each, it takes almost 2,000 electrons just to equal the mass of a single proton. To put that into perspective, it perfectly highlights just how unbelievably lightweight and fast these negatively charged particles are as they orbit the heavy center of the atom.
All right, Section 3, Modeling the Unseen.
Now, you might assume you need some multi-million-dollar lab to study atomic structure, right? Actually, scratch that. The absolute beauty of science is that you can build a highly accurate educational model using stuff you probably have lying around the house right now. We're talking paper circles, bottle caps from the kitchen, craft beads, pebbles from the driveway, or honestly, just drawing symbols on paper. It makes this invisible world completely accessible to all of us, right at our own desks.
Let's walk through how you'd physically map this out using those everyday materials. Step 1. Create the nucleus right at the center of your workspace. Step 2. Place your protons and neutrons, using, say, your beads or bottle caps, securely inside that center nucleus. Step 3. Draw those circular electron shells out in the empty space surrounding the core. And finally, Step 4. Place your lightweight electrons out on those rings. What's so fantastic about doing this by hand is that it forces your brain to lock in the exact spatial geography. You literally build the relationship between the heavy core and the active outer shells.
So the absolutely crucial point here is summed up perfectly. The nucleus contains protons and neutrons, while electrons are found in shells around the nucleus. If you remember just one concept from this entire explainer, let it be this blueprint. Heavy, positive, and neutral particles form the dense core, while tiny negative particles form the dynamic, moving boundary on the outside. That's the architecture for copper, salt, water, and literally every material we touch on a daily basis.
But as we wrap up, I want to leave you with a fascinating puzzle, straight from the source material. Why are protons and neutrons fundamentally bound together in the nucleus, while electrons are strictly found zooming around outside it? Like, what unseen forces actually dictate this precise, universal arrangement of charges and masses? It's a huge question that really challenges our grasp of the physical laws of the universe. Definitely something to chew on the next time you pick up a metal spoon. Thanks for joining me for this explainer. Keep your curiosity alive and keep questioning the invisible world around you.